I am at Iidabashi Station, located in the center of Tokyo. The stations for the Tokyo Metro Yurakucho Line and Nanboku Line are lined up, with the JR Chuo Line local service to the east and the Tokyo Metro Tozai Line station to the northeast. However, the line I am introducing this time is the Toei Oedo Line, located on the north side of the station, slightly away from the busy commercial district. From the underground passage connecting the various subway lines, I head toward the Oedo Line ticket gates. The Yurakucho Line opened in 1974, and the Nanboku Line opened in 1996. This is a common interior seen in stations built during the era of the former Idan subway, the predecessor of Tokyo Metro, but it does not continue for long. The newly constructed passage accompanying the opening of the Oedo Line Iidabashi Station in December 2000 has a different interior from the sections up to this point. The floor is made of exposed concrete, and the side walls and ceiling are made of folded metal plates. The lights are not embedded in the ceiling, and some are slanted relative to the passage or intersect with each other. I go down the escalator ahead. The passage that branched off earlier passes below here, and both eventually lead to the same destination. In addition, that passage also has an escalator in the middle, but it is preceded and followed by stairs. Lines with later opening dates are located deep underground, so long escalators are not uncommon, but this one belongs to a considerably long category. After passing through a space with an interior like a science fiction movie set, I reach the ticket gate level of the Oedo Line. This is the 4th basement floor, and I descend 3 levels from the 1st basement floor. At this location, the ceiling panels change to a mesh structure, and the bases of the lighting fixtures become visible. The Oedo Line ticket gate is located around the corner from here. I aim for the exit to the back right for a moment without entering the gates of this space, which is characterized by its monotone-based interior. Since this area was also built at the time of the Uedo Line opening, the interior is the same as before. This passage continues to the ground level exit and includes an escalator. However, this escalator ends at the final section. Furthermore, there are no elevators in the locations I have seen so far, including the connecting passage to the Tokyo Metro station. Because the entrances and exits are integrated with general buildings, escalators and elevators could not be installed. At the entrance, there is also guidance for people using elevators. In addition, when taking Tokyo Metro lines from this entrance, it is necessary to pass next to that ticket gate. This involves a flow of moving down to the 4th basement floor and then up to the 1st basement floor. But since walking on the ground avoids redundant vertical movement, it seems that almost no users of the Tokyo Metro lines use this entrance. I return to the underground. The fact that this area is integrated with the building is evident in the construction of the wall on the left and the ceiling. The scenes I have seen so far, like the area inside the ticket gates I am about to introduce, are related to the content of this video. The ticket gate I returned to is on the left side of the diagram. There is one more ticket gate, and they are connected via the platform. However, the distance from the ticket gate to the platform is long, and there is a curved connecting passage in between. I enter the area inside the ticket gates. The first thing that catches my eye are these components extending from the ceiling. In addition to being arranged as if penetrating the concrete of the ceiling in places, these components, which also serve as lighting, are called web frames. In the year 2000, when the internet was becoming widespread, the design was likened to the web where information is exchanged freely, carrying 2 meanings. 1, a physical transportation network connecting the city's underground, and 2, the subway as the city's information network. The arrangement of the frames was determined by a program. However, if everything is left to the program, frames may intersect at angles that cannot actually be constructed, so minimum conditions to be observed were decided, allowing the program to arrange them freely within that range. Regarding construction, the parts where the frames intersect were made first, and the rest were made by aligning the positions. Considering maintainability, the lights are placed in locations that are not very high, and specialized cleaning equipment was reportedly created to make cleaning easier. From here, the connecting passage shown in the earlier station map continues. The passage on this side is over 80 meters, 260 feet long, and the track has a sharp curve with a radius of 140 meters, 460 feet. In the slit-like lighting on the left and right, fixtures are omitted at a rate of 1 in every 6, and there are ventilation openings connecting to the tunnel here. Where the curve ends, the passage continues to the platform. Here, the floor color changes from black to white, and the impression changes completely. And I noticed something. The color of the walls is different on the left and right sides. The Uedo Line passes through a deeper location than other lines, and the passage became long due to the positioning of the ticket gates and the platform. Of course, there is a reason for this structure as well. In the earliest plans, the Uedo Line is intended to use large vehicles 20 meters, 66 feet long per car in 10-car formations, the same as the previously opened Shinjuku Line. With such a plan, sharp curves could not be made, and Iidabashi Station was not scheduled to be built in order to disperse congestion by reducing transfer stations with other lines. However, the adoption of the linear motor system to reduce construction costs and the use of a mini-subway with short vehicles made it possible to create sharp curves. At the same time, by reducing the number of cars to 8, the platform length could be shortened from over 200 meters, 660 feet, to 137 meters, 450 feet. The route was changed after a policy was adopted to increase users by increasing transfer stations with other lines, and the construction of Iidabashi Station was decided. This positional relationship and the long passage resulted from making the platform straight while keeping the tunnel under the road as much as possible. In designing the station, the goal was to create a space that was not monotonous rather than making the entire massive facility the same. The floor color of the passage changes from gray for the stairs and escalators to black for the connecting passage and white for the platform to provide contrast by separating colors. The circumstances this station faced are related to such a design. Iidabashi Station belongs to the section called the Loop section that surrounds the center of Tokyo on the Uedo Line. Among the stations in the Uedo Line Loop section that opened simultaneously in 2000, the approach to the budget was different from the previous sections. On the Uedo Line, where reducing construction costs was the ultimate mission, the figure obtained by dividing the construction amount by the station scale, construction unit cost, was originally low, but the budget was reduced each time a section opened, and Iidabashi Station was built with a considerably low unit cost. If the entire station is constructed the same way with this unit cost, the facilities would look cheap overall. But contrast is achieved, and such a situation is prevented by using structures without ceiling or wall coverings and floors with a concrete finish. On the other hand, as an accent to the monotone interior, brass components are attached to the edges of the stair steps, with consideration given to making the steps visually easy to recognize. Furthermore, stone and stainless steel are used around the entrances where it is easy to get wet from rain, taking maintainability into account. In addition, at the ends of the stair handrails, the handrails are coiled. This provides a slight elasticity when gripped and simultaneously serves as a marker indicating the beginning and end. The fact that the number of coils differs depending on the location is full of playfulness. And the high ceiling at the center of the platform is also part of the cost reduction. The platform and the passages before and after this station are excavated by combining 3 shield tunnels. A shield tunnel is made by attaching a cutter to the tip of a cylindrical machine to dig the ground and fitting concrete components called segments to the inside of the excavated area to build a tunnel. This method is often used for deep tunnels that cannot be excavated from the surface, and since there is extra space above and below the platform, it is normal to place pipes and air conditioning ducts here. To prevent these from being seen from the platform, finishing panels are usually attached to the ceiling, which tends to make the ceiling low and create a sense of pressure in stations with this structure. However, at this station, in addition to making the piping space under the floor larger than usual, a space to put ducts above the tracks was created, allowing the platform ceiling to be omitted for a clean appearance. In exchange, the ceiling above the tracks is perfectly flat, and the air conditioning vents are located near the edges of the platform, creating a design rarely seen at other stations. At first glance, it looks as though the ceiling was simply omitted, but many ingenious efforts were made for that purpose. Furthermore, this component at the boundary with the passage is part of a segment used for tunnel construction, representing the idea of intentionally showing the structure. The platform is also full of ingenuity. The different colored walls seen earlier are an effort to make the positional relationship visually easy to understand in a subway where the scenery is not visible. Platform doors were installed after opening, making it harder to see than when it first opened, but it still makes an appeal. Also, it appears that only the colors are different while the components themselves are the same, indicating an awareness of cost reduction. And these pillars lined up on the platform. These are finished with concrete, and the advantage is that they can be made thin due to their strength. On the other hand, since there is no choice but to pass pipes for rainwater and other fluids outside the pillars, covers with matching colors are attached to prevent the sense of unity from being lost. I direct my attention to the equipment next to this. The pink benches were added later, and only the middle one existed at the time of opening. The steel material with an H-shaped cross-section is literally called an H-beam and is a material commonly used in architecture. These benches, which incorporate the idea of showing the structure as it is, are characterized by a rugged appearance, but they include consideration for sitting comfortably with a wider seat width than before. For safety, the corners of the steel material are rounded. Equipment utilizing materials is not limited to this. The telephone stand is made by bending a thick stainless steel plate so that the thickness of the material can be felt. On the other hand, there is something like this in the center of the platform. This facility, which has an entrance on the opposite side, is labeled as a broadcasting room above the door. It is necessary to make the outside visible from inside the broadcasting room, but I want to avoid the interior being completely visible from the platform. To satisfy these contradictory conditions, a material called honeycomb core, which has an aluminum honeycomb structure sealed inside glass, is used. While it is visible from directly in front, it does not become transparent from all directions. Meanwhile, next to this is a bench made of a thick aluminum plate. Perhaps because it can be sat on from either direction, there is no other bench next to it. Of course, this bench also has rounded corners. At the end of the platform, the pillar design changes again. However, while the previous ones were finished with glass, these are covered with stone tiles. This is intended to make it easier to distinguish between the two while providing contrast by changing the construction for each passage. There is also a commitment to materials, with an effort to reflect light inside the glass so that lighting effects can be obtained without using electricity. Furthermore, while it is expensive to apply stone according to the shape of the pillars, using tiles lowers the cost and simultaneously serves as a light-reflecting finish to reduce a flat feeling. Since the walls on the left and right are also different, this should prevent getting the location wrong. I proceed further. This is not a transfer flow for other lines, so there are fewer people. This curve has a radius of 125 meters, 410 feet, which is gentler than the previous one, and the length of the connecting passage is slightly less than 60 meters, 200 feet, which is shorter than the previous one. It feels similar to the previous passage, but the construction of the wall surface is distinctly different. These line-shaped components are designed with the flow of the train in mind, and acrylic containing a fluorescent agent is placed inside the glass. This allows for a glowing effect even without lighting. And in this passage as well, the web frame appears near the end. However, this side is different from the opposite side. Because there are stairs and escalators in the middle of the curve, they are divided into 2 units. That is not all. While the platform was on the 6th basement floor and the previous ticket gate was on the 4th basement floor, the ticket gate ahead is on the 1st basement floor. The stairs and escalators that ascend 5 levels turn back in the middle, and the scale of the web frame becomes larger than before. That is this. Over the escalator, which is thought to be the longest in the station, the web frame is densely spread out. Certainly, with this, I should not be bored even on a long escalator. In addition, there is a machine room on this middle level, and even on the elevator connecting the ticket gate and the platform, there are buttons that normally cannot be pressed. Since displays appear on the 2nd, 4th, and 5th basement floors, and there are also doors, they appear to be used for moving equipment in and out. I go up the escalator and arrive at the ticket gate level. On the left is art using Braille. Since there are regulations for the size of Braille, these characters themselves do not make sense, but there is also Braille of a readable size among the characters found in various places. And I noticed something. Because this ticket gate does not have the mesh-like material on the ceiling, it feels brighter than the previous ticket gate. The 2 ticket gates can be distinguished from such parts as well. I go out to the ground from here. On this side, I can go from the platform to the ground by elevator, and exit C2 can be used. Instead of exit C2, which has an elevator, I intentionally use exit C3. The reason the area around the ticket gate was bright might be due to sunlight leaking in addition to the ceiling finish. Being a location away from the busy district, the surroundings are quite quiet, but when I turn around after reaching the top of the escalator, there is a structure with a certain presence. It looks like a roof for the entrance, but it is not just that. When viewed from a distance, elliptical components are attached as if surrounding the building. This is called wing, and it corresponds to the web frame that was underground. If that is the roots or branches extending underground, this is the trunk or leaves on the ground. This building is a ventilation tower, and because it has a top-heavy structure due to the arrangement of machinery, the wing is also arranged to widen as it goes up. It is difficult to understand from the outside, but there is a meaning to this arrangement as well. The Uedo Line Iidabashi Station, created in this way, received the Good Design Award in fiscal 2001 and the Architectural Institute of Japan Prize in 2002. In particular, receiving the Architectural Institute of Japan Prize for a railway station was a feat not seen since the Tokaido Shinkansen in 1964. These 2 plates are displayed next to the first ticket gate I passed. However, nearly 23 years have passed since the station opened, and the times are changing. Water leakage, which is the fate of underground stations, is seen in places, and there are locations where water catchers are attached to the concrete surface. The same applies to the concrete of the floor. Since the ceiling panels and floor finishing were omitted, it is quite noticeable. On the same Toei subway, there is an example at Takanawa-dai Station on the Asakusa line where water leakage became severe and panels were added to the wall surface to improve aesthetics. Furthermore, there are locations where the surface of the pillars is peeling off and the passage of years is appearing in various places. There are also chipped parts on the pillars at the edge of the platform, but since these components are not always mass-produced items, it is unclear if they can be easily replaced. The wing that appeared at the end also has a photocatalytic coating to reduce the maintenance burden, but there are still places where dirt is noticeable. Furthermore, although it could not have been fully anticipated at the time, the telephone below here was also removed following the decrease in public telephones. It is indeed lonely that it has become just a plate. And at this station, when it first opened, there were fewer signs and the station interior was clean. To avoid having to post notices outside of designated areas, the display spaces were made wider than usual, but they were not used and notices were posted all around. As the staff on site change, it is not uncommon for the goals aimed for at the design stage to change. On the other hand, ingenuity is also seen, such as blocking unused advertising spaces with materials that harmonize with the surroundings.